Hey everyone, just looking at a video today where we are continuing the ideas from last time on polar coordinates, and today we'll be focusing on changing polar to rectangular back and forth. And just wanted to highlight some of the formulas we saw last time. Converting polar to polar, right, is so we're looking at these two right here. If you want to change from polar to polar, I just basically need to change my angle is usually what I'm looking at. And then if I add or subtract 2 pi, the r stays the same. If I add or subtract pi, then I can change the r to the opposite sign. So from positive to negative or negative to positive. So those are ones that we kind of reviewed last time. This time we'll be focusing more on these right triangle formulas because these are what you'll use, all of these right here, when you are changing from polar to rectangular or rectangular to polar. And they kind of come in two groups. These first two, notice you get x in terms of r and theta, y in terms of r and theta. So usually this is when you're given polar, the r and theta, you just plug them in and then you can get out the x and y. The other way, right, if I have an x and y and I want to find the r and the theta, then I use these bottom two. So knowing x and y, then I'll use these bottom two to figure out what is the r, what is the theta that goes with it. And that direction is a little trickier, so we'll go through that here in a second. Let's go and start with a couple of these. So these are going, like I said, the easy direction, just convert from polar to rectangular. So we're going to use these two formulas right here, right? Given polar, this is an r, right? This is a theta. I'm going to just say x is this r cosine theta, and y is the r sine theta. Once I get that, then I can just kind of plug and chug, is usually how these go. So we'll just plug in the r. So we got 6, plug in the theta, cosine 2 pi over 3. And this is where knowing your either unit circle or reference angles are really good. Y, same thing, plug in the r, plug in that cosine 2 pi over 3. And if these are unit circle values, they'll usually be looking for an exact answer. A lot of times that's what they want. If they're not unit circle angles, then you can just plug that into your calculator and get a decimal out, and that will be fine. But these are values on the unit circle, so let's go ahead and see what those might be. So we got 2 pi over 3, right, is going to be right up here in quadrant 2, and we'll be using 6 is our r, so we'll move 6 units out in that direction. But that 2 pi over 3 normally has a cosine that goes over just negative 1/2, right? So this would be 6 times negative 1/2, which is negative 3. And then the y, same deal, looking at, oh, looks like I put cosine instead of sine for that one. Looking at the sine, go and change that. Sine of 2 pi over 3, that's going to be a positive root 3 over 2, going up that way. So we'll say y is 6 times this positive square root of 3 over 2. And the 2 will divide into 6, give me a 3. So this is 3 square root of 3. So that is the x and y, depending on how you need to list it. This is fine, just listing it like that. Or sometimes they want it a coordinate form, which I would put my x first, then my y, so negative 3, and then 3 square root of 3. And that would be final answer right there. This works for basically any combo that you want to do. So any of them that you want to do, it's fine. If we look at this one, 3 negative pi over 2, right? This one, negative pi over 2, right? It's my angle, which is down this way. And we're going to go 3 units out down here. All right. This one, you could use the formulas. You could also just think about, right, if I went 1, 2, 3, down 3 units in that direction, where would the x and y be? So that would be x is 0, right? I'm on the y-axis, not moving anywhere. And the y would just go down 3 units, so y would be -3, and that's it. So some of these you can draw out, maybe figure it out if it's a nice angle between quadrants on the x or y axes. You wouldn't necessarily have to use the formulas, but the formulas would still work if you just plug those in. Let's do this last one, and then we'll go the other direction. So this one will say, same deal. Let's kind of figure out where that is. -5π/3. All right, so that's going to go around this way till I'm up here, and then 5 units out. So normally, let's see what we get. This is x is positive, y is positive. So we got x is r cosine theta, and this is going to be square root of 3. And cosine of theta at that π/3 angle, right, that's going to be 1/2. So again, like knowing unit circle values, right, if this is at π/3 or this -5π/3, I'm going to get a coordinate on the unit circle of 1/2 √3/2. That cosine is going to correspond with that 1/2. So we would just get the x is √3/2. Doing the y, right, so y is r sine theta, and the r in this case, square root of 3, and we got sine of that theta, which is the -5π/3. Right, so -5π/3, sine of that is that √3/2. So say y is this √3 times √3/2. If you want, you can put that first √3/1 if you would like to see the fraction when you multiply it. So √3 times √3 is just 3, and 1 times 2 is 2. So this is 3/2. No square roots left in that one. There's my x, there's my y again. If we want to write that as a coordinate, this would be √3/2 for the x and 3/2 for the y. So that's it. So that's the basic gist. Like I said, that is the easy way, right, of going from any r and theta polar coordinate into rectangular, mostly using, right, these first two formulas that are kind of right here. That x is our cosine theta, y is our sine theta. The other way, we'll do in a second, is a little trickier. It uses these tangent is y over x, right, and the x squared plus y squared is r squared, that Pythagorean theorem. So we'll go and do a couple of those next. So let's try this first one, A. We got 3√3 -3, right, is our coordinate, and we want to convert from rectangular to polar. And notice these two things right here, they're going to narrow it down, right, because there are lots of polar coordinates that end in that same location. So they're going to narrow it down to try to get you to kind of like a final answer where r is bigger than 0, so r is positive, and your theta is between 0 and 2π. So no negative angles, no angles bigger than 2π. That's kind of the restriction they're using to narrow it down to a single polar coordinate that they're looking for. So let's go and try this one. The first thing I always do is just draw out which quadrant I'm in. It doesn't have to be super accurate, but 3√3 would be somewhere over here, positive direction. And then -3 would be somewhere down here, negative direction for the y. So that's going to put our point somewhere in quadrant 4. Right? So I can kind of think of it that way, somewhere in quadrant 4. What I want to do now is go ahead and use those values to find my r and my theta. Usually the r is probably like the easiest one to work with, and then the tangent, it just has one tricky spot where you have to be careful that you're in the right quadrant when you use inverse tangent, and that you have the right angle based on this restriction of 0 to 2π. So let's go and see what we got. So r, I'm going to say we got r squared, right, is our x squared plus y squared. Plug in the x and y, right, so this is 3√3, it's going to get squared And we got a -3, that's going to get squared. So this would be a 9 times 3, which is 27 for this one. And then -3 squared is 9. So we got 27 plus 9, which is 36. So this is my r squared. Now normally, when we're solving for r, we put a plus or minus after we take the root. So r could be plus or minus, right, square root of 36, which is 6. But what we want in this one is a positive r, right? They told us that r needs to be bigger than 0. So I'm just going to say r is positive square root of 36, which is 6. So normally you would include plus and minus, but because of the situation we're in, we only want to use the positive one. So this is going to be my r. The angle comes next, right? And the angle is going to be given by this tangent, right? So tangent of theta is y over x. And what I'm going to do there is say tangent of theta is this 3 root 3 divided by -3, right? Once I got that, then these 3's on the outside of the root will divide out, and I just end up with this negative square root of 3. So negative square root of 3 is my tangent of theta. Now, what you want to do next kind of depends on your situation. You could do an inverse, right, which is kind of what you want, but that will give you just angles between negative pi over 2 and pi over 2. So that is okay as long as you recognize that may not be your final answer, right? The other thing you can do is kind of look at the unit circle, figure out where in quadrant 4 is that going to take me for that guy. But let's go ahead and see what we'd normally get if we're looking at a unit circle value. So the unit circle, tangent's negative root 3. Tangent usually has just, we'll stick with quadrant 4 where it's negative, but one of these 3 values, right? So it's either 0 undefined if it's on the x or y axis, and then it's one of these 3 if it's in the middle. So how do you remember where these go? Well, -1, right, that's right in the middle. That's at all the pi over 4 angles, which we don't have, so it's not going to be in the middle. So it's either going to be closer to the x or closer to the y-axis. Now, closer to the x, this will have a smaller slope, and closer to the y, that'll have a steeper slope. So more shallow slope, I guess technically bigger or smaller, depends on, gets weird with negatives. So I'll just say it's a slope closer to 0 if you're over here close to the x-axis, and that would be this one, right? This fraction is closer to 0 than the root 3. Which we're not using, so that means I should be closer to the y-axis on this guy, so somewhere down here. And that's going to correspond with one of my pi over 3 angles. And in quadrant 4, that is a 5 pi over 3, right? So you get, for up here, pi over 3, 2 pi over 3, 4 pi over 3, and then 5 pi over 3 down there in quadrant 4. So I would just jump straight from unit circle to saying that theta is going to be 5 pi over 3. We are looking for an angle between 0 and 2 pi, so that's what we get. I do want to make another note on this real quick, but we'll go ahead and record our final answer, right, is 6, 5 pi over 3. Some people like to do some alternative methods, so they might do an inverse tangent, right, with degrees, because degrees gives you sort of nicer numbers. You would find that's negative 60 degrees, and then you'd have to get past that negative right angle, you'd have to add 360 to get back to 300, and then you could convert that 300 back to 5 pi over 3. So sort of a roundabout way if you don't know the radian unit circle values, but it would work. Just take inverse tangent right on your calculator, see what it gives you in degrees. Make sure you get that between 0 and 360, and then just convert that back to radians. So, but it is looking for a radian angle because it did say it wants that 0 to 2 pi. So this 6, 5 pi over 3 would be our final answer. Let's go and do just one more here. We'll do part C. You can try part B on your own if you want. But this -3, 4, let's go and try that one. So again, I'm going to look for which quadrant are we in. So -3 would come out this way, and 4 will go up for the y, so somewhere up here. So we're going to be in quadrant 2. Notice this -3, 4 is not going to be on my unit circle anywhere. And we'll see, even if we were to divide out, we're going to get a tangent value that's not going to be something on the unit circle. So we're going to have to use probably calculator or Desmos for this one. So let's go and start with, let's see, the r. The r is the easiest, so r squared is going to be this x squared plus y squared. And we're plugging in -3. So -3 squared plus 4 squared. So that'll be 9 and 16, which is 25. And that's r squared, which means r, again, would normally be plus or minus 5 with that square root. We're only using positives for r for these problems. So we'll say r is +5. Right, so that's it for that one. Once we got the r, then it's time to look at the theta, right? So we got tangent of theta is y over x. So in this case, that would be this 4 over -3, or -4/3 if you want to write it that way. This is not a value on my unit circle, right? Unit circle tangents are always 1 over √3, 1 or √3, or 0 undefined if you're in between quadrants. So this is going to be one that you have to do with Desmos in the calculator. So let me go and pull up Desmos real quick, and then we'll tackle that. All right, so I got my Desmos pulled up here, and I wrote my tangent over here. Tangent of theta is that -4/3. And what we want to do, let me go and pull that, sorry, back up. What we want to do is go ahead and on this guy, just write that inverse tangent of 4/3. So let's go and do that. So I'm going to go to functions. There's an inverse tangent right here if you don't want to type it all the way in. And then I'm going to do -4/3. Right? So -4/3. That will give me some value there. Right? So that's going to give me this -0.927 number. This is not the final angle I'm looking for, but I'll go ahead and write it. Right, so theta is that, and let me go ahead and I'm going to split the screen just a second so I don't have to keep popping it up. All right, so I got the screen split. So that theta is going to be this -0.92729, right? So we'll say 0.927. Really, we could round that up to 3, -0.9273. That is not between 0 and 2 pi. So if we want to angle between 0 and 2 pi, then what do we have to do? We have to add 2 pi to that. That will still be over here, or wherever this is. First, I guess we should ask, where is this before we add 2 pi? This angle, right, is going to be somewhere down here, actually, in quadrant 4, right? Because inverse tangent, right, is going to always give us something between -pi/2 and pi/2. So this is actually right here, this -0.9273. Right? We don't want anything in quadrant 4, right? We want something in quadrant 2. We want our positive. So what I'm going to do to that is add pi, right? If I add pi, then I can go ahead and just go all the way back around to here just by adding pi, right? So that's going to be plus pi. It's going to take me back around to quadrant 2 from quadrant 4. So I'm going to go ahead and put that in. So let's see if I can copy and paste that in. Oh, it doesn't look like it's working. Nope, so I'll just type it in. So we got -0.92, let's say 729, 295. We'll put a few extra decimals in there, and then we're going to add pi, right? So that gives me this 2.2148 number that's right there. So I'm just going to say over here plus pi, and then theta is this 2.21, we'll say 49, round it up to 4 decimals. So there's my r, there's my theta. Again, if you want to write that as a coordinate, you can. So we got 5, comma, 2.2149. So that's it. So just be very careful, right? That extra adding pi step is not intuitively obvious if you're just using the formulas. It makes sense if you have a picture off to the side. So I always recommend when you're going from the direction of rectangular to polar, always draw a picture, see what quadrant you're in, see if the angle you get from the inverse tangent makes sense, and then go from there. All right. One last thing that we'll talk about before we go. What polar coordinate corresponds to the origin, right? So the origin's right at 0, 0. So I'll let you think about that for a minute. So right here, the origin in rectangular has a special name in polar. It's called the pole. All right, so sort of like North Pole or South Pole, this is just the pole. There's only one in polar coordinates. And what coordinates would it have? So I'll let you think about that a second. You can pause it if you want a little extra time to think. All right. So with this one, how far out are we going, right? What is our r? And how far around are we going? What is our theta? Those are the two things we need to know. The r is going to be 0, right? We're not moving any distance away from that center point. So that is going to be 0 for that r coordinate. The theta, though, what angle do I need to make? Well, I can actually do any angle that I want. So I could go somewhere over here in quadrant 2, but not move anywhere, right? If I'm not moving anywhere, I'm in the same place. So I can turn my body to face whichever direction, but if I don't move, I'm just going to stay put. So this can actually be any coordinate for that angle. It doesn't have to be 0, 0. It can be 0, comma, any angle that you want. That's always going to be kind of that central, what we call the pole. Next time we'll take a look at converting equations. These, again, have one direction that's kind of straightforward and one direction that is a little trickier, using kind of the same formulas that we did for converting the coordinates. So we will take a look at that in the next video.